Our topic for today, it's all about multiplying radicals with different indices. Now, as we all know, in multiplying radicals, if the indices are the same, we just copy the index and then we multiply the radicals. So example, square root of 2 multiplied by square root of 3, the answer is square root of 6. So once again, in every square root, the index is 2. You can put 2 or you can leave it as blank. Okay, that's the same with square root of 6. Now, if the indices are different, we do some other methods. We need to convert, or we need to transform this radical into exponential form for us to proceed in multiplying radicals. So we have example. We do have two examples here. So our first example, the indices are different. So square root, this one is 2 and the other one is 3. But we have the same radicands. Okay. So it's easy for us to answer this example number 1. Now, what if the indices are different at the same time, the radicands are different? So we do other ways to solve for this one. So without further ado, let's solve for number 1. So let's transform this square root, okay, into exponential form. So for square root, so this is 2, copy 2. Understood that the exponent here is 1, so 1 will be the numerator and the index here 2 will be the denominator. This is equivalent to 2 raised to the power of 1/2. So once again, if you're having hard time to convert this radical into exponential form, do not be worried. I will put a link on the description below, so feel free to see it. Multiplied by this one is the cube root of 2. So copy 2. Understood that the numerator, the exponent here is 1. So 1 will be the numerator. 3 here is the index, will be the denominator. So that is 2 raised to the power of 1/3, or read as the cube root of 2. Now, if the bases are the same, okay, do not forget in the product rule, if you still remember, a raised to the power of n multiplied by a raised to the power of m. So if the bases are the same, you can simply copy the base, then you will add the exponent. Okay, in the product rule, in the laws of exponent. So if the bases are the same, copy, then add exponent. Since we do have the same bases, so we can actually write this as copy the base. So 2 raised to the power of 1/2 plus 1/3. Okay, copy the base, then add exponent. So 1/2 plus 1/3, we do have 3 ways to answer 1/2 plus 1/3. First way is first solution is we need to find the LCD. It depends on you, class, which do you prefer. So to find the LCD, you think of a number that we can divide 2 and 3 by that number. So, or to get the multiples or the least common multiple of 2 and 3. So 2 and 3. So multiples of 2, we have 2, 4, 6, 8. Multiples of 3, 3, 6, 9, so on and so forth. And the least common multiple of 2 and 3, that would be 6. Alright, so 6. So this will be, if you still remember, in adding fractions. So I do have a link in adding fractions. Please feel free to see it. So 6 divided by 2. So 6 divided by 2. This is 3. Times 1 is 3. Plus 6 divided by 2 is 2. Times 1 is 2. So 3 plus 2, that would be 6. No, that would be 5, sorry. 3 plus 2, that would be 5. Then copy the denominator, 6. So that's 5 over 6. So this will be 2. 2 raised to the power of 5 over 6. Now, you can also add 1/2 plus 1/3 using butterfly method. So this will be the case. 2 times 3 is 6. You get the product of 1 and 3. 1 times 3 is 3. You get the product of 2 and 1. 2 times 1 is 2. Then you add. So this is 3 plus 2, that's 5. Copy 6. Same answer, 5 over 6. And the last method is we need to get the common factor. So it depends on your class, which do you prefer. For example, 1/2 plus 1/3. Okay, 1/2 plus 1/3. We need to get a common factor of 2 and 3 in which you can make it by 6. Okay, because the least common multiple of 2 and 3, that is 6. So you can multiply this 1/2 here by 3. So common factor, that would be 3. Multiply it by 3. And for this one, to make it 6, you multiply it by 2. Multiply it by 2. So 1 times 3 is 3. 2 times 3 is 6. Plus 1 times 2 is 2. 3 times 2 is 6. Now, in adding fractions, if the denominators are the same, just simply copy. Then you add the numerator, 5 over 6. So it depends on you. Which do you prefer? So that would be the same answer. So for number 1, so you write this in radical form. This is, so this will become, the answer will be the 6th root of, okay, 6th root, okay, 6th root here, the index here is 6, the denominator, so the 6th root of 2, 5 here will be the exponent, raised to the power of 5. Or, you can simplify this one, the 6th root of, okay, the 6th root of 2 raised to the power of 5, it means you multiply 2 by itself 5 times. So 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. The 6th root of 32. So that's our answer for number 1. Alright, so that's our answer. Now, what if, okay, let's answer number 2. Okay, that's our answer for number 1, 6th root of 32. Now, sir, what if the radicands are not the same, as well as the index? So, example, the square root of 2 multiplied by the cube root of 3. So, the thing that we will do right here, class, is we need to convert this into exponential form. This will be 2 raised to the power of, exponent here is 1. So 1 is the numerator. Index here is 2. 2 will be the denominator. Multiplied by, copy 3. So 3. Exponent is 1 will be the numerator for the fraction. And 3, the index here 3 will be the denominator. So 2 raised to the power of 1/2 times 3 raised to the power of 1/2. So we cannot apply the product rule. Sir, why we cannot apply the product rule? Because the bases are not the same. We can only apply the product rule if the bases are the same. But as we all know, in radicals, we can multiply radicals. Example a while ago, okay? Our first example, if the index are the same, okay? If the indices are the same, so you can copy the indices, then you can multiply the radicands. Example, square root of 2 multiplied by square root of 3. You can copy the indices and then you can multiply the radicands. So this is square root of 6. Okay? Now, if the indices are different, so the thing that you will do is you need to get the common factor of 1/2 and 1/3. So, or the least common multiple of 2 and 3. Of course, that would be 6, right? Okay, we can simplify it by 6. The least common multiple of 2 and 3, or the common factor, that would be 6. Now, to get 6, you multiply this one by 3. The other side, you multiply this one by 2, so that the indices will be the same. Okay? So, instead of 2 raised to the power of 1/2, okay, this will be 2 raised to the power of 1/2. Okay. 1/2, you multiply it by 3. You multiply it by 3. You multiply it by 3 over 3. And for this side, 3 raised to the power of 1/3. Sorry. 3 raised to the power of 1/3. You multiply it by 2 over 2, or 2 and 2. Sir, why is that? So that the indices will be the same, because 2 times 3 is 6. 3 times 2 is 6. Now, if the indices are the same, according to the rules of radicals, okay, in multiplying radicals, we can easily multiply if the indices are the same. So this will be, okay, This is 2. 1 times 3 is 3. 2 times 3 is 6. So 2 raised to the power of 3 over 6 multiplied by 3 here. So copy 3. 1 times 2 is 2. 3 times 2 is 6. Okay. Once again, do not forget, we get the common factor of 1/2 and 1/3, which is the common factor to get 6. We multiply it by 3 over 3. And for 1/3, we multiply it by 2 over 2. Why is that, sir? So that we can get a common index, which is 6. Because the least common multiple of 2 and 3, that is 6. Now, we convert this one into radical form for us to multiply. So this is 6th root of 6, 6th root of 2 raised to the power of 3 multiplied by, okay, once again, the index here, the denominator will be the index. Copy 2, 3 here will be the exponents. Multiplied by the 6th root of, okay, 3 raised to the power of 2. 2 here will be the numerator, 6 will be the index. Now, since the indices are the same, okay, but before we multiply, simplify this one first. 2 raised to the power of 3, this is equivalent to the 6th root of 8. 2 times 2 times 2 is 8. Then, multiplied by the 6th root of 3 times 3 times 3 is 9. 3 times 3 is 9. 3 squared is 9. So, multiply. Once again, if the indices are the same, copy. So, the answer is the 6th root of 8 times 9. So, 8 times 9, that would be 72. So, sir, can we simplify this one? Okay, we can. Okay. But you think of a number that when we multiply it by itself, you will get 72. I think there's no number when we multiply it by itself. We get 72. We can actually simplify this by the cube root and square root. Okay, square root of 9 times 8. We can do that if you want to. But this is actually okay, class. 6th root of 72. So this is our answer. Okay, 6th root of 72. Because we don't have a number that when we multiply it 6 times, we get 72. Because into 2 times 2, that would be 4 times 2. That's 8 times 2. That's 16. Times 2 is 32. Times 2 is 64. Times 2 is 128. So, it's already 7 and we didn't get 72. So, this will be our final answer. So, that's it. That's how you solve if the radicals, if the radicals have different indices. So, that's the thing that you will do is you need to transform that to exponential form and proceed to multiply the radicals. So, that's it.